Ayata's ProClimate. Grid stability. Integrating renewables with actionable wind and solar forecasting using AI. Learn how accurate forecasting using AI is critical to integrating renewables into the power grid. Wind and solar accounted for 10.3% of global electricity generation in 2021, up from 1% in 2020. To limit global warming to 1.5 degrees centigrade, as targeted under the Paris Agreement, solar and wind power need to continue growing at a rate of over 20% per year. Wind and solar power suffer from a significant disadvantage versus traditional sources of energy generation. They are non-dispatchable and intermittent. Said differently, they produce energy only when the wind blows or when the sun shines. The continued growth of intermittent renewable power depends on having a stable electrical grid on which that power is placed. With the advent of renewables, grid spending needs to increase over historical levels. The Brattle Group estimates that $1.5 trillion to $2 trillion will be spent by 2030 to modernize the grid just to maintain reliability. However, blackouts are growing more frequent in the United States. The average American experienced just over 8 hours of power outages in 2020, with overall duration of power interruptions in the U.S. more than doubling since 2015, according to the U.S. Energy Information Administration. The blackouts in California in 2020 and Texas during February of 2021 only serve to underscore these points. Complex problems like integrating large amounts of intermittent power onto the grid will require a number of different solutions working in concert with one another. For example, energy storage via batteries allows power to be shifted from when it is generated to when it is most needed. Another solution is undoubtedly better forecasting the factors that generate renewable energy for both wind speed and solar irradiance. Massive grid modernization efforts can only be accomplished over years or even decades. In contrast, improvements in wind and solar forecasting will yield immediate benefits. Grid operators generally plan to meet supply and demand on a day-ahead basis, if not further into the future. So, if wind and solar cannot be accurately forecasted more than 24 hours into the future, then they cannot be incorporated into the grid's plan for the next day. If intermittent power then generates more than expected, the power is often wasted as other plants were dispatched to meet demand. If less power is received than expected, the grid operator has to compensate with more expensive ancillary services or backups like a spinning reserve. Solar and wind forecasting is typically limited in that the models that forecast temperature well don't accurately predict wind speeds or solar irradiance. As such, the most advanced solar forecasting can accurately predict irradiance less than 24 hours into the future. And wind forecasting demonstrated by Google's DeepMind shows good results up to 36 hours ahead. Ayata's ProClimate renewable forecasting system uses artificial intelligence, real-time satellite imagery, and government weather data to improve the accuracy of wind and solar forecasts by over 30%, up to 36 hours for solar irradiance forecasting, and up to 72 hours for wind speed forecasting. Trying to maintain a grid without accurate forecasting of renewable power is like driving a car using only the rearview mirror. Ayata's solution allows grid operators to better plan for the wind and solar being added to their grid daily, reducing the need for high spinning reserve or costly ancillary services. To summarize: Number 1. Wind and solar power are growing rapidly, but they are intermittent and difficult to forecast. Number 2. Electrical grids worldwide, particularly the US grid, suffer from underinvestment and are ill-prepared to integrate renewables. Number 3. Properly integrating intermittent renewables requires better forecasting of wind speed and solar irradiance. Number 4. Existing forecasting technologies don't predict wind and solar well, and AI enables new forecasting engines with much higher accuracy, much further into the future.